Okay guys, in this video we're going to look at how we can use the dot product in order to help us find the magnitude of a vector. And so what I'm going to start with really quickly here is just kind of a sketch of the situation, but imagine we have a vector that is in standard position. And so we have it starting at the origin and terminating at some point here. And so if I call this vector v, let's assume that this is v1, v2. The interesting thing here is that in terms of length, okay, we say that the length of these are their magnitudes here, but we have the two components here, horizontal and vertical, that would add together to make up our, I guess, hypotenuse part of this, or resultant vector here, which was our initial vector. When we take a vector and a dot product with itself, what I want you to see happens is this, and maybe I'll write it down here, is this. We get v1, v2, and a dot product with v1, v2. And we all have been taking dot products today. We know that we multiply our horizontal components. And so we've got v1, u1 plus, sorry, v1, v1. If I can read my own handwriting here. We got v1 times v1 plus v2 times v2. Multiply our vertical components. When you do this, though, what results is this v1 squared plus v2 squared. And where have we seen this before? Well, whenever we take the length of this leg squared plus the length of this leg squared, what we get is something that is the hypotenuse. And so it is fair to say that what we end up with here is the dot product of a vector with itself giving us the square of the legs added together. But what would have to be true about that? We would have to admit that that would have to be equal to the magnitude of the vector itself squared. And so I'm going to throw a box around this up here and basically admit that whenever we take a dot product of a vector with itself, we're always going to take this component squared plus this component squared. And so we know that we get the magnitude itself squared. And that's what's going to help us find then the length of the vector. So looking at number 25 here, what I want to do is kind of visualize this first. And so I am going to look at this is a vector that went left 8 and up 15, and so I can kind of imagine that it would maybe terminate right here. And what I want to acknowledge is that if this is the point left 8 up 15, then to find the magnitude of this vector, remember that u and a dot product with itself equals the magnitude of the vector squared. We already know the vector u, and so what we're going to do is we're going to go ahead and do this left side. Okay, and then when we find that, because that's the length of the magnitude squared, we're going to take the square root of this, and I want you to kind of see how this plays into this and how Pythagoras would be really similar. And so what we get is this. We get negative 8 comma 15 and a dot product with itself. We know that this has to be the magnitude of the entire vector squared. And so the reason why this happens is because we get negative 8 squared plus 15 squared. That has to be equal to the length of the vector u itself squared. And so what we get is 64 plus this here is 225, and I believe that this gives us 289, but let's check this out here. We get 289 then equals the magnitude squared. And so by wanting the magnitude, we have to take the square root of both sides of this relationship here, but essentially what we get here is 289. Oh man, why can't I think of this? Is 17, I'm pretty sure here, but we'll take the square root of 289. Having an off day. It is indeed 17. So we get 17 is just the magnitude of u. And so looking at it this way, we say, okay, well, yeah, that kind of makes sense. If you do a dot product of a vector with itself, you're going to get the horizontal component squared plus the vertical component squared. That's got to be the square of this vector, its magnitude. But when you look at it, you know, kind of as a, well, how does it relate to Pythagoras? We're still going to square both components and add them together and then take the square root of those. It's just that we wanted to show it this way. Okay, and so for the rest of these here, go ahead and find the dot product of the vector with itself, but then take the square root of your result, and that should give you the magnitude of your vector, just as we've found magnitudes in the past. Cheers.